black surface you drive on is the thinnest and least important part of a highway. Almost everything that keeps that road alive is buried underneath it, and most of it went in before a single drop of asphalt arrived. A highway starts as a line on a survey. Engineers walk the corridor with total stations and satellite receivers, fixing the center line to within a few millimeters and recording the height of the ground every few meters. That survey becomes a three-dimensional model of the finished road, and every machine that follows will be chasing that model. On a modern job, the grader and the dozer are steered by it directly. The operator watches a screen showing how far the blade sits above or below the design surface, and the hydraulics correct automatically. Before any of that, the corridor has to be cleared. Topsoil is stripped and stockpiled because topsoil is full of organic material that rots, compresses, and leaves voids. You never build a road on it. Trees, stumps, and soft pockets of clay come out with it. What is left is the natural ground the whole structure will stand on. Now comes the largest and most expensive phase, and it is pure earth moving. A highway wants gentle gradients and gentle curves, but the landscape rarely offers them. So engineers cut through the high ground and fill the low ground. And the ideal design balances the two, so the material taken out of a cutting is exactly what is needed to build the embankment a kilometer later. Moving soil off-site is expensive, so a balanced cut and fill is worth real money. Fill is never dumped in one go. It is placed in thin layers, often only 200 to 300 millimeters deep, and each layer is compacted before the next one lands. That layered approach is the single most important idea in road building. You cannot compact a thick pile of soil. The roller only influences the top portion, and everything below stays loose, waiting to settle years later and take the road surface down with it. The finished, compacted natural ground is called the subgrade. It is the foundation. Before anything is built on it, crews will often run a proof roll, driving a heavily loaded truck across the surface while an inspector watches for movement. If the ground flexes or pumps water, that section gets dug out and replaced. Fixing a soft spot now costs a few thousand. Fixing it after the road opens costs a fortune. On top of the subgrade goes the subbase, usually 6 to 18 inches of coarse crushed rock or gravel. Its job is partly structural and partly hydraulic. Structurally, it spreads a concentrated wheel load out over a wide area of soft soil, the way a snowshoe spreads your weight. Hydraulically, its open, stony structure lets water drain sideways out of the pavement instead of sitting under it. Water is the real enemy of any road. Saturated soil loses most of its strength, and trapped water under a slab turns into a hydraulic hammer every time a truck passes. Above the subbase sits the base course, typically 4 to 12 inches of tightly graded crushed stone, sometimes bound with cement or bitumen. This is the main structural layer. The stones are deliberately sized so that small pieces fill the gaps between large ones, and when the roller passes, they lock together into a dense mass that behaves almost like rock. Every one of these layers is compacted and surveyed before the next goes on, and every one is built with a slight crossfall, a gentle tilt of around 2% toward the edge, so water runs off rather than soaking in. Only now does the asphalt arrive, and it usually comes in 2 or 3 passes. First, a binder course, a coarse, strong asphalt mix that carries the load and takes up the small irregularities in the base. Then the surface course, a finer mix chosen for grip, noise, and durability rather than strength. That top layer is often only 40 millimeters thick. It is the part everyone sees and the part everyone thinks of as the road, and it is essentially a wearing surface, a sacrificial skin protecting the structure below. When a highway is resurfaced, that is usually all that gets replaced. The paver lays each mat at close to 300 degrees, and a train of rollers follows immediately to squeeze out the air before the mix cools and stiffens. Alongside it, the drainage system goes in. Ditches, French drains, gullies, culverts under the embankments. Engineers will tell you that a road fails from water far more often than from traffic, and the drainage is what keeps the expensive layers below dry. Not every highway is finished in asphalt. Some are built in concrete, and the two behave in completely different ways. Asphalt is flexible. It bends slightly under every wheel and passes that load down through the layers to the soil, which is why what sits underneath it matters so much. Concrete is rigid. A concrete slab is stiff enough to bridge over a weak patch of ground and carry the load out to its own edges, so it leans far less on the layers below. That rigidity is why concrete pavements are laid in slabs with joints cut into them, sawn within hours of the pour before the concrete can crack on its own terms. Concrete costs considerably more to build and is slower to repair, but it can last 30 or 40 years before major work. Asphalt is cheaper, quicker, quieter to drive on, and easy to resurface overnight, but it needs that resurfacing every 10 to 15 years. Most countries end up with a mix, choosing concrete where traffic is heaviest and closing the road later would be hardest. The last stage is the part that makes it a highway rather than a strip of asphalt. Safety barriers, signs, lighting, and thermoplastic line markings sprayed hot and dressed with glass beads so headlights reflect straight back at the driver. Then the whole corridor is inspected, cored, and tested. So what does all of that cost? For an ordinary rural interstate, roughly $7 million a mile. Push it into a city with land to buy, utilities to move, and structures to build, and 11 million is a starting point, with complex urban projects running many times higher. In the most expensive states, a single lane mile can pass 8 million on its own. That is the price of everything under the surface. And when a road does fail early, the cause is almost never the asphalt. It is a subgrade that was never properly compacted or drainage that stopped working. Follow for more construction facts hiding in plain sight.